Chalo, keep reading. Newton's laws of motion. We are dealing in two separate topics का. One is without friction and आगे with friction आने वाला है. पूरा friction मतलब क्वेश्चन में friction मतलब different types of friction क्या क्या पढ़ने वाला है, पूरा पढ़ने वाला है. Okay, kinetic friction, limiting friction, static friction और सब कुछ पढ़ेंगे. Okay, so this is without friction. This is happy, tension नहीं है. Okay, so this all comes till now we done kinematics, right? Now we are doing dynamics. Dynamics is separate topic है. Dynamics बोल तो क्या है? We will see in the kinematics. What is the difference between kinematics and dynamics?
Kinematics has friction.
No, kinematics is friction.
Sir, dynamics is no friction.
See, dynamics में we are dealing with friction also. आगे topic. See, dynamics में we are seeing cause and effect. Kinematics में we are seeing only the effect. मतलब the body is moving. What is acceleration? What is velocity? Like that we studied in kinematics. Dynamics में why the body is moving. That cause also we are seeing. Okay, cause means why the body will move from one body to one point to other point. Tell me. Why the object will move from one place to other place? Because of what? Because of applying what?
Motion.
Object force. Force we are studying in this. Dynamics may we are seeing the cause the object is moving. That force we are studying in this. Okay. So first basic things you know. What is force means? Concept of force we'll study. What is force? Simple definition. Tell me. Force means
Push or pull.
a push or pull on a body is called force. Simple force. And you know it is a vector quantity and SI units is Newton. Just a push or pull को we call as force. So because of dynamics पूरा force के बारे में पढ़ने वाला है. Full dynamics में पूरा force. Like आगे you know in circular motion also we'll talk about centripetal force. All force के बारे में only. Okay. Next. Done. Okay. Now classification of forces. We classify forces into two major categories. Okay. Can you guess what are the two major categories of forces?
Contact, non-contact.
What?
Contact and non-contact.
Ah, yes. correct.
Balanced.
No, no. That is 9th class ka. Contact force. And what is meaning of contact force means forces that act between bodies in contact. Two bodies in contact. Then that type of then the force coming is nothing but contact force. Can you give examples where two bodies in contact, the forces, contact forces, some examples? Tell me.
Sir, friction.
Friction. Next.
Sir,
Tension force, normal reaction force, spring force, and friction force. All will be coming. Normal reaction force means मालूम है ना? Suppose in this table के ऊपर I put one book. Okay. The book के ऊपर some force is acting. That is normal reaction. Free body diagrams में detail में will see. But normal action is always perpendicular to surface. Perpendicular to surface. Okay. And tension force मालूम है. Tension force कब आएगा? Whenever there is a rope. Whenever there is a rope, there is a tension force. Rope or string on it, anything like you know. That is their tension force will be coming. Spring force, you know, whenever spring is there, usko we extended, we elongated or compressed, spring force will be there. And friction also. Two bodies, whenever they are relative motion, whenever there is a relative motion between two bodies, then there is a friction force. Okay, this all comes under contact forces. Two bodies in contact. Okay. Next one is non-contact force. मतलब दो बॉडी कांटेक्ट नहीं हो रहे, even though body is not in contact with air, even though it is in space also, in air also, some force will be acting. Examples?
Gravitational force.
Gravitational force, electrostatic force, which we studied in class 12th. Okay.
So the nuclear force.
So forces that act between bodies in separated by distance without any actual contact. Even though the separated by distance also, the force will be acting. That force is nothing but non-contact force. Weight is also force, right? What is the units of weight? What is the units of weight?
Newtons only.
kg.
Yes. No. Mass is kg. Weight is Newton.
Oh, mg. Yeah, correct.
Okay. Electrostatic force and gravitational force. These all comes under non-contact force. After finishing all laws, we have to go detailedly this all things. Friction is separate chapter only, one chapter on separate topic only. And wait, electrostatic force will study in the 12th class में. Gravitational force gravitation chapter में पढ़ने वाला है पूरा डिटेल में. Okay. कॉपी कर लो.
Yeah, sir, I wrote.
Yeah. Very depth में जाने वाले हैं. Understand each and every topic. Covered.
Yes, sir.
चलो. Now, next one. Newton's first law of motion. Laws of motion में Newton's first law. Newton's first law already you know, right? What is Newton's first law? Says
An object in rest stays in rest, and object in motion stays in motion unless a force is acted on it.
suppose if I put a pen on the table, if you go for 10 days outside also, the the pen will be there only. The object at rest will be at rest. When I throw object, it will be continuing in the continuation in uniform motion only. Like, in space mein, if I throw object in space, what will happen with 5 meters per second? After 10 years also, if you go also, the object will continue to be at 5 meters per second only. Unless until some external force acts on it. That is a Newton's first law. Okay. So that means whenever object के ऊपर net force is zero, whenever object के ऊपर net force is zero, that condition को we call as equilibrium. That condition को we call as equilibrium. When net force is zero, you know that already acceleration will be zero. When acceleration is zero means velocity is constant. Velocity is constant means velocity is vector quantity, right? Magnitude and direction is constant. That means the object at rest will be at rest only. Object in motion will be in motion. मतलब will object in motion means उसका magnitude will be also same and direction also will be same. Then only it will be continuing with the same velocity. Okay, that is the Newton's laws of motion. My first law. Okay, and this definition, by seeing this definition, it is some other name we can give. What is that name? Which name we can give instead of
Inertia.
Newton first law? Inertia. Okay, inertia means similarly the object always resist the sudden motion में. Okay, the object want to rest me. Suppose big stone is there. If I given certain force, it will not move because object at rest want to be at rest initially. Okay, some opposition will occur, right? That is called inertia over there. That's why this Newton's first law is also called as law of inertia. Law of inertia. Copy it?
So, sir,
Next.
Newton's first law of motion, F net is always zero.
Net force is zero. This one, then only this all things will happen. No net force should unbalanced force active auto, it will not stay in rest, right? That's why equilibrium. Whenever net force is zero, is called as the equilibrium. बोलते हैं. Okay, inertia का definition लिखो. Inability of a body to change by itself its state of rest or state of uniform motion along a straight line is called inertia of a body. Okay, to change itself by state of rest, it will not change by itself the state of rest or motion. That property we call as inertia. And already we have three types of inertia: inertia at rest, inertia in motion, inertia in direction. This is all you studied in the 9th class. Now second law understand होने के लिए we have to know one terminology which is called momentum. Momentum के बारे में little bit if you know, then second law easily you can able to understand. Covered?
Yes, sir.
चलो. Now linear momentum. Okay. So momentum मालूम है. Momentum is product of याद है?
Mass and velocity.
Mass and velocity. Okay. Product of mass and velocity, and we represent momentum as p, and formula is mass into velocity. M is mass, v is velocity, and p is called momentum. And SI units is, by seeing the formula we can tell kg
kg meter per
meter
second.
per second. Basic thing we know. इसमें किधर से which law is so important? Which law is so important for us numericals के लिए? Tell me.
Third law.
First law ना, second law ना, third law ना?
Third.
Third नहीं है, second law is most important. Second law का question, so many questions will be there. Okay. Like पुल्ली problems आएगा, इधर उधर कितना है पूरा, कितना अच्छा free body diagram आएगा, that much easily you can solve the questions. Short formula लिख लो. Momentum, mass, velocity. Okay. Now we'll go for Newton's second law of motion. You know the definition of Newton's second law? Second law बोल सकते हो? What is the definition of Newton's second law? हाँ कृषा बोलो.
F equal to ma.
It is- हाँ
F is equal to ma.
हाँ F इक्वल टू एम ए बोल के हम लोग सोचेगा, बट F इक्वल टू एम ए इज नॉट ए न्यूटन सेकंड लॉ. वो एक स्पेशल केस है वेयर वी यूज F इक्वल टू एम ए. ओके, सो वेरी इंपॉर्टेंट, वेरी क्लैरिटी यू शुड अंडरस्टैंड. सो न्यूटन सेकंड लॉ क्या बोल रहे हैं? दैट द रेट ऑफ चेंज ऑफ मोमेंटम is directly proportional to applied external force. Okay, so momentum ka p, right? Rate of change of momentum is delta p by delta t. This is the rate of change of momentum is directly proportional to force applied. This is the Newton's second law. Rate of change of momentum is directly proportional to force. When I remove, we'll get a proportionality constant, and experimentally they found that proportional constant is 1. Therefore, F is equal to delta P by delta T. This is the second law. Anybody if they ask what is second law means, F equal to ma नहीं है, वो एक special case है where we derive from this. We'll derive also. F equal to ma कब use करेंगे we'll see. So F equal to delta P by delta T. इसमें so many questions are there. JEE मेंस में भर के आएगा. Change in moment, rate of change of momentum. And the moment किधर change हो रहा है momentum, उसी direction में the force also will act. So direction of applied force के direction only the momentum will change. Okay, done.
Yes, sir.
Yeah. Now we will derive F equal to ma वाला. F equal to ma. देखो suppose मान लो object of mass m, it is moving with velocity u. I am applying a force F acting on it. Okay. So what will happen when I apply a force? The mass, उसका velocity will change. इसको velocity है v. मान लो after certain time t के बाद उसका velocity got changed to v. Okay. Then initial momentum कितना है? Initial momentum is mass times velocity mu. Final momentum will be mv. So I want change in momentum, which is p final minus p initial. So mv minus mu. This is a change in momentum. And we know from Newton's second law, F is equal to delta p by delta t. So delta p के जगह में m कॉमन ले रहा हूं, m टाइम्स ऑफ v माइनस u by कितना टाइम में चेंज हुआ, वेलोसिटी t. And what is v minus u by t is called as acceleration. Therefore, F equal to ma. See here, when we have to use F equal to ma, when mass is constant. Very important. F is equal to ma when we have to use when mass is constant. देखो, that's why only we can able to take the common. देखो, when mass is constant, I can take the common, then only I got acceleration. If mass is not constant, if m1, m2, I cannot take common, I cannot get acceleration. Okay. So whenever any question mein mass is remains constant, you can use, you will tell to find average force. F equal to ma you can use. F equal to ma is equal to, and mass is constant. Okay. You can ask why mass generally constant hai na? Why varying? Varying, any chances there? Tell me any example where mass is varying.
A rocket.
Okay. Any other examples? रॉकेट में करता हूँ. रॉकेट में क्या होगा, फुल मास रहे, वह जब जाने समय उसका गैसेस निकलता जाएगा, द मास विल डिक्रीज. सो मास इज कांस्टेंट नहीं है उधर. दैट टाइम व्हाट वी हैव टू यूज, वी हैव टू यूज दिस फॉर्मूला F इक्वल डेल्टा p बाय डेल्टा t. नॉट इसका कौन सा F इक्वल ma वी शुड नॉट यूज. ओके. एनी अदर एग्जांपल्स वेयर मास इज नॉट कांस्टेंट? एनी अदर एग्जांपल? आपको जनरली व्हेन यू डू द क्वेश्चंस में यू विल गेट, यू नो कन्वेयर बेल्ट्स मालूम है? कन्वेयर बेल्ट्स मतलब crusher plants में they they will, it will carry the load from one place to other place. Or again a simple example में a container is there, container में water getting leaking every second में, that the mass is changing or not in that में. At that time we can't use F equal to ma, we have to use delta p by delta t. Only when mass is constant we have to use F equal to ma. That's it. When our question में if they tell to find the force, simply you can use F equal to ma only when mass is constant. In that question mein mass is varying every second mein, we can't use this one. We have to use delta p by delta t. Okay. Chalo. Now in differential form mein we'll write Newton's second law in differential form mein. Tell me F is equal to, we know this one, delta p by delta t. In small interval of time mein we call as dt. In that small interval of time mein small change in momentum ko we call as dp. So F equal to dp by dt is called force. Okay, in differential form, and this is instantaneous force. dp by dt is nothing but instantaneous force. Normally F is equal to delta p by delta t is nothing but average force. Okay, this is average force. Delta p by delta t. Change in momentum by change in time. Many times में we will take initial question as per the question, initial momentum 0 मान के बोल सकते हैं, because initially मान लो the particle is at rest, ऐसा 0 मान सकते हैं. Okay, they will mention question में. Okay, चलो dp by dt. देखो what is, इसको थोड़ा simplify करेंगे. d by dt of momentum का formula is mass times velocity, and you know differential form uv का formula मालूम है ना, first into differentiation of second plus second into differentiation of first. This is the exact formula of the Newton's second law. This is exact formula. Why?
Instantaneous.
This is instantaneous. Okay, instantaneous means differential format, differential form. Okay, see, this is exact formula of Newton's second law. देखो, sometimes question में they'll tell every second mass is decreasing by 1 kg per second or 20 grams per second. So that time dm by dt, if we जगह में we have to write that one 20 kg ऐसा. Okay, and dv by dt, no, every second में velocity is getting changed. That one we have to substitute here. Okay, so this is the exact second law. Exact second law. See, second law may change momentum, but momentum, it can be changed. The velocity also changes, momentum will change. Either mass also change, momentum will change. So when both, if it change also, we can use this formula. From this I can derive F equal ma also. Tell me if mass is constant. Tell me if mass is constant, dm by dt is how much? Change in mass
Zero.
by time, 0. So therefore F का formula क्या आएगा? M into dv by dt is nothing but acceleration. F equal ma. So we can derive F equal ma from this also. So understand it, whenever Newton's first second law this says, don't tell F equal ma. F equal to delta p by delta t. That is a formula. Average force बोलते हैं. Instantaneous, particular instant में चाहिए बोले तो you can use dp by dt and you can expand this one. Okay. Anything. So they will mention question they'll tell mass is changing means you can use this one force at that time, particular time we can find the force. Okay, done. Understood? This is the second law. Done. Copy it. Chalo. Now we have to enter the third law. The chapter is going to finish, right? First law, second law, third chapter done, right? But इसमें बहुत सारे questions are there, बहुत things are there, new things are there. This is all we are studying like lower class till now. Okay. So Newton's third law, this famous law, even gully person will tell, right? What is Newton's third law?
Every action has an equal and opposite reaction.
Okay. Like छोटे time में खेलते हैं ना, if the person beat, you also जाके मारेगा, every action there is a equal and opposite reaction बोल के बोलेगा. Whether that is right or wrong. If you hit the person hits on you. Whether this is action and reaction or not. बोलो. Whether that is action, reaction or not.
No, sir.
No. Then उसमें action reaction का कौन सा है? Tell me.
Sir,
Explain
when
action.
you apply a force on him, and then he also applies a force on you. That is
That
action
only,
and reaction.
that only he's applying.
And then when he hits you, he'll apply a force on you, and then you will automatically apply a force on him. That will be his
Like
action.
lower classes में हम लोग पढ़ा होगा ना, if I push a wall, at the same instant में wall also pushes us. That is an action reaction pair. But you have to understand here thing, action and reaction acts on different bodies. That is important. Okay, we'll see. So Newton's third law लिखो, for every action there is an equal and opposite reaction. For every action there is equal and opposite reaction. Suppose मान लो एक टेबल के ऊपर एक बुक रखा. Okay, इसके ऊपर what are the forces acting on it basically, which we are saying? One is gravitation force, weight, and weight का फॉर्मूला मालूम है ना, आगे पढ़ने वाला है. weight का फॉर्मूला क्या है? mg. mg is always weight. The gravitation force is acting. You tell me, if only gravitation force is acting, the book will book क्या होगा? ये टेबल को ब्रेक करके अर्थ के नीचे चले जाएगा actually. But this is not happening. That means some other force is there exactly opposite direction, which is balancing the weight. That force is called as normal reaction force. Normal reaction force. Now देखो, whether they are action reaction pair, whether they are action reaction pair, tell me. बोलो.
No, sir.
Why?
So because action reaction pair have to be the same type of force. So like
Good.
the book.
Yes, उसके लिए some rules to understand that action reaction pair acts on different bodies. देखो, mg is acting on what? different bodies के ऊपर देखो I told her I am pushing the wall, I am applying a force on wall, the wall pushes me, that मतलब action reaction pair acts on different bodies. ओके इसमें देखो mg is acting, बुक के ऊपर mg force is acting and बुक के ऊपर normal action force is acting, so they are acting on same body. That's why we can, by the first rule we can eliminate that these are not action reaction pair. First point समझ में आ रहा है. Second point, action reaction pair are of same nature. Same nature means action force का reaction will be also same thing. Normal action is action means the reaction force is also normal reaction only. Gravitational force action means the reaction force is also gravitational force is also reaction force. Same nature रहेगा. Friction force का action reaction will be friction force only. ऐसा रहेगा. समझ में आ रहा है? So same nature will be there. And those are very important thing. Force always exist in pairs. Pairs में exist होगा. Pairs में exist होगा means tell me where is normal action here? Only one only. इसका pair किधर है? इसका pair किधर है? Where is that pair?
So downwards.
हाँ देखो the table is exerting a normal action force in the upwards. Same instant में the book also will exert a normal action on the downwards. So this is action reaction pair. देखो they are of same nature and they are acting on different bodies. These are action reaction pairs. Now mg का earth है ना, earth always pulls the object towards the center of the earth, right? Now this is action. The book also pulls the earth in the opposite direction, mg. So these are action reaction pair. They act in different bodies, okay, and they are of same nature. देखो normal action का reaction force will be normal action and mg का reaction force will be mg only. दोनों conditions should be satisfied. Then only we can say they are action reaction pair. Understood? Newton's third law. चलो copied. चलो ना करो. एक क्वेश्चन करो. Man A and man B, they are on the smooth surface. मतलब there is no friction. Smooth surface. They are fighting each other. हाँ ना करो and tell the answer.
So can you go back for a second?
Yeah.
Yeah, sir, done.
चलो करो. Man A of 60 kg, a person का 60 kg. Okay, pushes the other man B with 75 kg. तो दोनों weight दे दिया. Due to which the B starts moving with the acceleration of 3 meters per second square. So 3 meters per second square he is moving. Find the acceleration of the man A at that instant. That instant में I want to find the acceleration of A. Find करो.
So 3.75.
Yes, correct. He will apply a force on him with what force? Force on B due to A. At the same instant, according to Newton's third law, he also applies a force on A due to B. So according to Newton's third law, both are equal and opposite, right? So FAB in magnitude wise, I'm seeing is equal to FBA, right? And you know, force is equal to mass into acceleration. So 75 into 3, right? Because F equal ma, right? Here mass समझ में आ रहा है? F equal ma. Here इधर क्या होगा? Equal to F mass into acceleration of A.
Yeah, sir, 3.75.
So from this, AB is equal to 3.75 meters per second square. Why they are moving with different acceleration? Because weights are different. मतलब masses are different. Okay, समझ में आ रहा है? चलो. Now इसका application is there. Application is there. Newton's third law का, and second law also will be adding in it. Okay, that is conservation of momentum. वेरी इंपॉर्टेंट एप्लीकेशन, कंजर्वेशन ऑफ मोमेंटम. ओके, सुना होगा ना कंजर्वेशन ऑफ मोमेंटम क्या है बोल के. टेल मी व्हाट इज कंजर्वेशन ऑफ मोमेंटम. एनीथिंग डेफिनेशन 9th क्लास में याद है? Actually they deleted in that 9th class, right?
I think
Conservation
like
of,
initial momentum, final momentum, something like that.
okay, when we are to use any question, that is important thing. Anywhere we can use initial momentum equal final momentum or special condition mein. And what is that condition?
Still condition.
What is that condition? That's why I asked. Okay, we will see.
The masses of the body are equal and at the same
No.
acceleration acts on it. And
No, no, no.
velocity.
देखो, first लिखो. If no external force acting on the system, very important. If no external force acting on the system, the linear momentum system remains constant. मतलब देखो, we know that F is equal to delta P by delta T. This is the average force, right? Delta P by delta T. Okay. Now I can write, if this is external force, right? Indirectly is nothing but external force only. External force, average force, everything same. If external force is zero, external force is zero. In that condition, mein, if I substitute in the formula, mein, 0 is equal to delta P by delta T. From this, delta P is equal to 0. And delta P is nothing but final momentum minus initial momentum is equal to 0. Implies initial momentum is equal to final momentum. So initial momentum is equal to final momentum will be true only when external force is 0. Very important point. If external force is 0, then only initial momentum is equal to final momentum, and we are applying for system. Initial momentum is system, मतलब 2 or more bodies है तो सभी का you have to, initial momentum you have to add. This also you have to apply for system only. If 2 or 3 particles are there, सभी का momentums you have to add initial momentum. That is equal to final momentum also we should add. Only when external force is 0. Can you give an example where external force is 0 and where we can apply conservation of momentum? In
When
example,
acceleration is 0.
uh,
When net acceleration is 0.
okay. General example. Any example so that we can apply conservation of momentum. Simple है. Gun and bullet. देखो, when I fire, डिशूम बोल के fire करूंगा, the gun will exert a force on bullet. At the same instant में, the bullet also will exert force on gun. Action reaction pair, that is called internal forces, that is 0. And there is no external force, there is no other external force. In that case में, we can apply initial momentum equal to final momentum, because externally there is no other force. Internal forces cancel out each other. Okay, in that case में we can apply conservation of momentum. Very important. Gun and bullet का many questions will be coming. So आपको क्या है? Suppose gun is there, okay, bullet is there, okay. So if I fire the gun, क्या होगा? This will apply force on bullet due to gun, and same instant में the bullet also will exert a force on gun due to bullet. So their action reaction pair, they cancel out each other. Net force is 0. Net force is 0, right? No external force is 0. Internal force vectorially cancel हो जाएगा. मतलब if I add this 2 in vectorially, क्या हो जाएगा? That is 0. And there is no external force is 0. And external force is 0 in this case, right? Because externally there is no any other force कुछ apply कर रहा नहीं कर रहा ना. Internal. In that condition में we can apply initial momentum is equal to final momentum. Okay. So questions में आपको even this conservation of momentum, it is not only stopping in the Newton laws of motion, work per energy में आएगा, and आगे के chapters also, gravitation chapter also will be coming. But you have to observe that when you can apply only external force 0 है तो ही apply करो. And people को वो लोग options देगा. Even though external force is there, you will apply conservation of momentum. Answer आएगा that will be there in option, which is wrong. External force 0 है तो ही we have to apply conservation of momentum. Okay. समझ आ रहा है? So therefore, and gun and bullet में initially we always treat gun and bullet is a rest. Gun and bullet is a rest. So suppose मान लो इसका मास है कैपिटल M, इसका वेलोसिटी पीछे जा रहा है ना, वेलोसिटी v, इसका मास है स्मॉल m, उसका वेलोसिटी इज u. Okay, so mass u. So what will be the answer? फॉर सॉल्विंग के लिए क्या करने का, इनिशियल मोमेंटम इज जीरो सिस्टम का, मतलब गन एंड बुलेट दोनों रेस्ट में है इनिशियली, दैट्स व्हाई इनिशियल मोमेंटम इज जीरो इज इक्वल टू फाइनल मोमेंटम। फाइनल मोमेंटम क्या होगा टेल में, बुलेट का कितना है, m इंटू यू। हाँ, इसका इसका क्या बोलेगा, वेलोसिटी पीछे जाएगा ना, गन विल बी रिकॉल, राइट, रिकॉल जाएगा पीछे जाएगा ना, सो माइनस m इंटू वी, बिकॉज वेक्टोरली वी शुड राइट। ओके, so from this you will tell to find velocity, recoil velocity बोलते हैं इसको। so from this what is the recoil velocity, v is equal to mu by capital M, this is called recoil velocity। recoil velocity। so gun and bullet में majorly generally we will treat initial momentum as zero। in some problems also when you are applying, always don't think initial moment is not given ऐसा नहीं, to check initially starting, initially gun and bullet में they will not mention that initially gun is rest, bullet is rest, ऐसा नहीं, आपको लेना पड़ेगा initial momentum zero बोल के, because gun and bullet before firing it is rest। तो मेरा इसी में आपको बर बर के क्वेश्चंस आर देयर, वी आर डूइंग नाउ, मेनी जेई मेंस क्वेश्चंस भी है, पूरा क्वेश्चंस आर देयर, बेटर सॉल्व नाउ। ओके, करेंगे, स्टार्ट करेंगे, चलो। एप्लीकेशन, द गन रिकॉइल्स व्हेन बुलेट्स आर फायर्ड फ्रॉम द गन, रिकॉइल वेलोसिटी मेजरली पूछेगा, रिकॉइल वेलोसिटी। इवन यू नो सपोज एक शिप इज देयर, you are
So
there,
the recoil velocity will work for any condition.
recoil velocity means gun, recoil velocity means what is the meaning of recoil velocity, पीछे आने वाला वेलोसिटी, रिकॉइल वाला, इन द गन एंड ओनली वी विल टेल रिकॉइल बोल के। ओके,
Yeah,
इवन
so,
यू नो,
so will it work for anything like if
हाँ,
like any situation?
any situation में it will work, like you know, boat and the person, yeah, suppose the person is coming down, at that time boat will go backside, right, boat will go backside, that is called recoil, the recoil इसका। so क्या होगा मालूम है, why is coming going back, what will happen, because he is applying a force on you know the you know ship, and the ship also applying a force on him, action reaction pair cancel out each
So
other।
then the mu by m, the small m is the mass of the gun,
गन,
and
no no,
u is
small m
the
is the bullet का, bullet का, and this is gun का, बड़ा m is gun,
so then u is the velocity at which the bullet is shot.
bullet only, and this is gun का। so आपको मेथड से करो, ऑलवेज डोंट यूज दैट फॉर्मूला, ऑलवेज इनिशियल मोमेंटम इज इक्वल फाइनल मोमेंटम करके सॉल्व करके आंसर बोलने का, राइट। चलो, तो इसका न्यूमेरिकल्स वी विल डू, हाँ करो। A 1500 kg gun mounted on the wheels shoots 10 kg projectile with velocity, मतलब बुलेट का मास एंड उसका वेलोसिटी दिया है, पैरेलल टू द हॉरिजॉन्टल, सीधे जा रहे हैं, फाइंड द हॉरिजॉन्टल रिकॉइल स्पीड ऑफ द गन, पीछे आने वाला गन का रिकॉइल वेलोसिटी इज आस्किंग, एंड उसका मास आल्सो गिवन। सो इन दिस केस में whether we can apply conservation of momentum means yes, because external force is zero, internal forces always cancel out each other, action reaction pair cancel out each other, oh, here no external force, that's why we can apply simply initial momentum is equal to final momentum, for system ko you have to apply, and for system ko you have to apply, and in this gun and bullet mein we should treat initial momentum as zero, because gun and bullet are rest, no fine।
So 5.33.
5.33, yes, correct। आया कृषभ पे, तो मास इंटू वेलोसिटी, सो बुलेट का कितना हो, 10 इंटू 800, गन का रिकॉइल का माइनस, सी इफ यू डोंट पुट माइनस आल्सो नो प्रॉब्लम, द आंसर विल बी कमिंग माइनस, मतलब इनडायरेक्टली इट इज रिकॉइलिंग बोल के समझ में आएगा। ओके, माइनस 1500 इंटू वी, so from this v you can find that is approximately 5.33 meters per second is answer। अगर इधर प्लस डाले तो क्या होगा, माइनस में आएगा, नो प्रॉब्लम, माइनस मींस इनडायरेक्टली वेलोसिटी राइट साइड पॉजिटिव, लेफ्ट साइड नेगेटिव, राइट, सो इट इज कमिंग बैकवर्ड्स। ओके, समझ में आ रहा है, चलो ना करो। A railway truck of mass traveling this much collides with another truck B, half of its mass, moving in opposite direction. Very important, opposite direction. With a velocity this much. They stick together after the collision, then the common velocity is. Okay. Uh, Here, initial momentum is 0 in this case. Because railway track is moving initially. There is no 0 here. Right? Solve करो. So railway track है. Some mass m1 मान लो. Moving
What
with
are the
velocity u.
options?
Huh? No
Options.
options. No options. Velocity u2. Opposite direction में जा रहे हैं. ये अटैच हो गया. दोनों अटैच होके m1 plus m2. दोनों अटैच होके and move with a common velocity v. That velocity is how much he is asking. So when it hits right, this is applying a force on this. At the same instant, this is also applying a force on this. Their action reaction pair, they cancel out each other. There is no external force. That's why we can apply in this case also conservation of momentum. So units always take care of all our meters per second, no problem then. Hmm.
Sir, I'm getting 0.26.
Yes, correct. So since they are initially moving, आपको initial momentum is equal to final momentum लगाने का. And I told you for system का means but how many particles आते हैं सभी का momentum ऐड करने का. इसका क्या होगा m1 u1 minus m2 u2 is equal to m1 plus m2. Final momentum will be m1 plus m2 into v. So from this you can find v, common velocity v. m1 सब values मालूम है, substitute.
Yes, I got it.
Yeah. So v is equal to 0.27 or 26 meters per second. चलो. Now JEE mains questions करने वाले हैं. So many questions came into the JEE mains पे. Generally क्या करेगा ये topic को they'll neglect. ये न्यूटन लॉस मोल तो खत्म. वो they'll tell free body diagram वो सब ऐसा नहीं. ऐसे questions आ रहे हैं भर के आ रहे हैं 23 years questions में. Okay. We will see questions. Easy भी है hard भी आएगा. चलो करो. And now tell the answers now. This is 2024. A body of mass 1000 kg is moving horizontal with velocity. Another body is added gently. Then what will be the new velocity?
Sure, thanks.
So is the answer 5?
Yes, 5 is the answer. I आपको मानो.
1 second.
Yeah. So body is moving initially. So there is an initial momentum is there. Another body is added. That means the final momentum में 1200 हो जाएगा mass into the velocity. New velocity. This is only 2024 में है.
Yes, I got 5.
Yes, 5. Because initial momentum equal final momentum equate करने का. ऐसा नहीं कि all cases में initial momentum is 0. Only gun and bullet का ऐसे initial stage में 0 मानने का. Okay. चलो next. Average force of 125 newtons is applied on the machine gun, firing bullets this much, speed this much. The number of bullets fired per second in the machine gun is.
So I got 50.
देखेंगे. We know the formula and momentum का relationship, Newton's second law. Use that one.
So do we convert that into kgs?
He's asking number of bullets. N value is asking. N number of bullets per second.
Or so do we
Gram to kgs. Yeah, compulsory.
So I'm getting answer is 500. 1 second.
Which formula used?
F
Pranav?
is equals to number of bullets into momentum.
Sir,
Okay,
total force should be equal to 125. 125 is equal to number of bullets into mass of one bullet into velocity.
देखो.
Into
F
acceleration.
is equal to delta P by delta T. This is average force, right? So F is equal to, this is final momentum minus initial momentum, right? By time. Okay. Now final momentum तो आपको मालूम है 10 grams, that is 10 into 10 power minus 3 kgs into velocity is 250. Okay, but एक बुलेट का नहीं है ना.
10 into 10. Oh. That's where I went wrong, sir. I wrote 10 power 3, 10 power minus 4 by mistake.
Okay, so ये एक बुलेट का मोमेंटम नहीं है. n number of bullets, right? So n number minus initial momentum 0 है because before firing. So always we should take that initial momentum like this by time. Time is 1 second, right? Number of bullets per second चाहिए. So if you calculate, you get F is equal to F के जगह में 125 by 250 into 10 power of minus 2 n. So कितना था? 2. So 100 by 2 is 50. So 50 is answer. So average force है ना? We can find it. Understood? Yeah. Second one. Next one. करो.
So the 180 bullets per minute means dm by dt is 180.
देखो dm dn
D. Oh.
मास नहीं है. See, always try to take bullets per second. N is the number of bullets per second लेने का by 60 करने का. So same much में gun वाला easy रहेगा. Gun of mass this much fires this much 20 grams of bullets at a rate of this much. मतलब N is given per second with the speed also given. Recoil velocity of the gun.
So it is 0.6.
अनम्यूट करके देखकर ना वीडियो ऑन करो. देखेंगे which one answer right. So gun and bullet internal forces will be cancelled. There is no external force. That's why we can apply initial momentum equal to final momentum. And solve.
0.6.
0.6, huh? Okay. This answer. आपको कितना है? अच्छा.
Sir, can you do it once?
देखो गन एंड बुलेट का व्हाट आई टोल्ड टेल में इनिशियल मोमेंटम इज इक्वल फाइनल मोमेंटम. वो तो समझ में आया. एक्सटर्नल फोर्स इज 0. इनिशियल मोमेंटम इज हाउ मच? गन एंड बुलेट में 0 राइट. इनिशियली गन एंड बुलेट इज एट रेस्ट. तो 0 इज इक्वल टू ये सिस्टम का अप्लाई करना राइट. एंड इसका आई टोल्ड यू बुलेट एंड गन का दोनों को मोमेंटम ऐड करना पड़ेगा. m टाइम्स ऑफ u माइनस m टाइम्स ऑफ v. दिस इज ओनली रिकॉल वेलोसिटी आई टोल्ड यू राइट. बट एक बुलेट नहीं है ना. हाउ मेनी बुलेट्स आर देयर? लाइक नंबर ऑफ बुलेट्स पर सेकंड चाहिए ना. तो n ले लो into n. n is what? Number of bullets per second. In this case में how many bullets per second? How many?
Sorry,
180 by 60 right? 3. Because per minute is given. Per second चाहिए 3. So n के जगह में 3. So therefore mv is equal to n times of mu. Now substitute. Bullet का mass is given. Initial velocity is given. n is 3. And mass of the gun also given right. 10 kg बोल के. Find v. Find करो. v is equal to 3 into bullet का 20 grams right. 20 into 10 to the power of minus 3 into initial velocity is 100 by m, mass of the gun. Mass of the gun is 10 kg. So 10 power of minus 2, 60 into 10 power of minus 2. So it is 0.6 meters per second. Gunner bullet का easy है कुछ नहीं. n number means n multiply with n. That's it. Number of bullets per second.
Yes, sir.
चलो. This is all JEE mains questions. बर के पूछा. A balloon has a mass of 100 grams in air. Okay. The air escapes from the balloon in a uniform
Sir,
rate.
what do you want the? So you want the answer in newtons only, right?
Which one?
The answer, final answer.
Previous one, huh?
No, sir.
Ah,
This
yeah,
question.
Newton. Yeah. I'll give options also. He told in dyne. No. Dyne. No need of converting anything.
So one dyne is like 10 power minus 5 or 10 power minus 7.
10 power minus 5. balloon है.
Suppose should we use that formula, the mdv by dt plus v dm by dt?
Oh, I can use anything. Force will get at that instant में. What is the force? Well, average force acting on the balloon. मतलब at that point also we can find directly. No problem. Initially the mass is 10 grams में.
There is 1 gram centimeter per second square, 1 dyne.
1 gram centimeters per second square is 1 dyna. आपको you convert into the normal formula में and will get in dynes last में. Directly kg को grams में convert कर लो and centimeter per second already is there. ऐसे रहने दो. हाँ, डायरेक्ट ग्राम्स ओनली, राइट? सो नो प्रॉब्लम, टेंशन नहीं.
So then it should be 9.
9, huh?
Yeah.
Yes, 9 is also. Use karo question. Try. These are JEE Mains 2022. A balloon has a mass of.
dm by dt into velocity. That's what I did.
Yeah, you can use this also. If you want like this, F equal to m into dv by dt plus v into dm by dt.
Yes, sir, but dv by dt is 0.
Because he told that the balloon is going in uniform rate with velocity this much, right? So the change in velocity is 0. A 0 हो जाएगा. So directly v into dm by dt. Velocity कितना है? 4.5 centimeter per second into dm by dt. कितना है? dm by dt is so 10 into 10 power of minus 2, 10 power minus 3. कितना होगा? 10 power minus 2 by time is 5 seconds. Right? कितना होगा आंसर? It is 9 dynes आएगा. 9 dynes.
Sir, why 10 power minus 2?
आपको ग्राम्स में दिया ना? ओके, 10 only you can use, right?
Only for 10 per minus
हाँ,
2.
10, yeah, sorry. So directly no need of converting.
Yes, sir, it will be 10 per 2. If you are converting in dynes, it will be 4.5 into 10 per 2 by 5.
No need here because dynes में centimeter all of the SI units इसमें है ना? So कितना होगा? F equal to 45 by 5 is 9. Okay, समझ में आ रहा है?
Yeah.
So we can use this one. We can say this is instantaneous, right? By average में use कर रहे हैं. Average force means at that time में what is the force acting? Also we can find average force, right? कर सकते हैं? Energy है? कृष्णा? हाँ, करो. Last problem करें, हो जाएगा.
So recoil velocity is 0 in this question.
A ball of mass this much hits the.
What is it same as the initial speed?
This is initial speed, and bounces back with changing the initial speed. Okay, without changing the initial speed, the force is this much. Calculate the time down. Recovery नहीं है इसमें. Why is not just?
There are options.
Options you want? 0.018 seconds. और seconds में. Calculate the time of duration. Force is given. We know the favorite formula, right? Second law. Use that formula and solve. Question understood? So एक बॉल है. आंसर क्या?
0.0185.
How much?
0.0185.
और किधर 185. ओके देखेंगे.
0.036.
ओके देखेंगे. A ball of mass velocity u जाएगा and again coming back to the same velocity.
Yeah, sir, even I'm getting 0.036 because it becomes 2 velocity, right?
आंसर 0.06. देखो फोर्स फार्मूला क्या था? फोर्स इज डेल्टा पी बाई डेल्टा टी. व्हाट इज चेंज इन मोमेंटम हियर कृष्ण? टेल मी. इनिशियल मोमेंटम इज mu, फाइनल मोमेंटम माइनस इनिशियल मोमेंटम, राइट? और इनिशियल मोमेंटम माइनस फाइनल मोमेंटम मैग्नीट्यूड वाइज. देखो डेल्टा डेल्टा पी कितना टेल में कृष्ण? इसका आंसर कितना है? डेल्टा पी 0 आएगा. नो नो, राइट? 0 विल नॉट कम.
So, zero. Okay.
हाँ, ऐसे सोचेगा. वेलोसिटी वेक्टर क्वांटिटी है, इस तरफ जाने समय माइनस लगाना पड़ेगा. ओके, तो इफ यू टेक दिस एज पॉजिटिव, दिस एज नेगेटिव, इफ आई टेक द मैग्नीट्यूड, देखो mu माइनस ऑफ माइनस mu, because when you coming this side we have to put minus vector quantity momentum, so minus of minus plus 2mu आएगा. So it is 2mu by delta t. So f you know, m you know, velocity you know, substitute will get time.
Yeah, got sir.
कृष्ण ने सुना? कभी भी याद रखिए, ऐसा क्वेश्चन आपको आईपीबी में आएगा, इसमें भी आएगा. पीपल ऑलवेज सोचेगा कि 0 आएगा, बट 0 नहीं है. चेंजिंग लॉ, चेंजिंग मोमेंटम विल भी डबल हो जाएगा उसका. तो ऐसा क्वेश्चंस और भी है, सब मोर क्वेश्चंस करने वाला है नेक्स्ट क्लास में पूरा. मतलब नेक्स्ट क्लास मींस आपको मोशन प्लेन का थोड़ा रिवाइज करके उसका नेक्स्ट क्लास में विल डू.
Okay, thank you.